Hello, my name is Jonathan from the Max Planck Institute for Software Systems, and I will present to you a work that I did with Adish and Goran, also from the Max Planck Institute for Software Systems. So I would like you to imagine that you are a model developer, and what you might find yourself in situations in that you get some user feedback. For example, users might say that your model produces offensive jokes, but only in German, and other languages are generally considered safe. Or there's an election with a new president, and your model was now trained on outdated data. Or users might want to generate codes using your language model that have not been tested on. In all three of these cases, we want to test our model for very specific kinds of instructions. So for example, about jokes in German. And what you might do is just collect prompts about this topic and just throw them at your model and see if something harmful comes out. But the problem with this is that whenever you do this, these prompts has not specifically been done for your model, but are just basic intuitions and asking about this kind of behavior. So what we want to do is we ask ourselves, can we modify this reference prompt in such a way that the intent is still maintained? So we still ask about, in this case, how to knock someone unconscious, but maybe we slightly rephrase it and add some more detail. And with these additional modifications, we want to have the following. So while our original reference prompt does not result in harmful behavior by our target LLM, the new modified prompt should. And you can imagine yourself that you are in some kind of space and you have your reference prompt in the middle and you have some kind of budget around it, which we call epsilon. And you want to find modifications that when you apply these vectors to your original prompt, it does not exceed the budget, but results in harmful behavior. So don't want to exceed the budget, or you also don't want a version of your prompt that is harmless. And what we did is we use modifications in embedding space inspired by the fusion models. And what this basically means is that we take our reference prompt and embed it. So you can think of this as a representation of the embedding space, where our reference prompt is in the middle. And then we train our tag model to predict a noise vector, which we can add to our model. For example, we get here. We then can use techniques to revert this point in the embedding space into human and LLM readable prompts. And we get a modified prompt, which we input into our target LLM, which gives us an output. And this we can create using a reward model, which we then use again to update our tag model. And with this technique, we first found that established Rotimi models based on autoregressive techniques are actually really bad at this kinds of modifications. So if you can see, if we just use unmodified prompts, so basically just use the modified prompts as is, and then apply modifications used on an autoregressive model, it can actually decrease the amount of toxic responses. So we might modify them in a way that they are less harmful, which is actually the opposite of what we want. Now, if we use our diffusion idea, basically this modification in the embedding space, we actually found that even with allowing very small modifications of epsilon equals to 0.1, for comparison, this modification uses epsilon 0.5, so it's even less than this. We can already find some prompts that originally were not considered harmful, but now are. So the amount of toxic responses slightly increased. And as we increase the budget, we can find more and more toxic responses that are similar to our reference prompt. Using this, we can do a targeted security assessment, where basically we took a data set of prompts classified by the area of harmfulness, we modify them, and we just test how likely are we to find harmful responses from our model. And with this, we can find that this specific model is very secure with regards to violence and privacy, while having some kinds of issues with controversial analytical topics issued by the high text success rate of our diffusion model.